Hi, in this video we're going to talk how to use a velocity graph to work with acceleration, displacement and distance traveled of a particular particle or some other object. So we have this graph that represents the velocity of that particle that's moving along the x-axis. We know that the position of the particle at t equals 0 is going to be 5. So the first question is, at what values t is the particle going to be at rest? It's going to be at rest wherever the velocity is 0. So it's going to happen at 2, at 8, at 11, and at 16. So at t equals 2, t equals 8, t equals 11, and t equals 16. So the second question related to that is, at what values of t does the particle change direction? It's going to change direction where not only the velocity of the particle is going to be 0, but also the velocity is going to change direction. In other words, it's going to change from positive to negative and negative to positive, and we also want to explain that. So it's going to happen at 2 because the velocity goes from negative to positive, at 8 because it goes from positive to negative, at 11 negative to positive, but not at 16. At 16 the direction does not change. So at t equals 2, 8, and 11 because v of t changes sign. Okay. All right, I'm going to be referring to this graph. I'm going to be going back to it every now and then because we'll need to see it. So our next question is, on what intervals is the particle moving to the left? And explain. It's going to move to the left wherever the velocity is going to be negative. So where is the velocity negative? 0 to 2, 8 to 11, and that's it. So it's going to be on the interval from 0 to 2 and also 8 to 11 because v of t is negative. On what intervals is the particle moving to the right? And explain. So it's going to move to the right wherever the velocity is positive. So from 2 to 8 and 11 to 19. At this point it comes to a stop, but remember it does not change direction, so that's what it's going to be. So it is going to be from 2 to 8 and 11 through 19 because v of t is greater than 0. I will note that it happens except at t equals 16, but remember the particle does not change direction at t equals 16. Find the acceleration of the particle at t equals 7. Well, if you remember the relationship between the acceleration and velocities, the acceleration is going to be the derivative of velocity at that same point. So all we need to do essentially is figure out the slope of the velocity graph at 7, which is right here, and the slope of this line is -1. So it's -1. Is the particle speeding up or slowing down at t equals 7? Okay, so what do we know about the velocity and what do we know about the acceleration at t equals 7? If we already know that, if we look at the graph, that the velocity is positive at 7, right? It's +1. It doesn't matter exactly what that number is at this point. So the velocity at 7 is positive. We already know that the acceleration at 7 is negative. Therefore, if I can spell this right, therefore the particle is slowing down. Because when the velocity and acceleration have opposite signs, that means the object is slowing down. Find the acceleration of the particle at t equals 12. At t equals 12, it's the slope of this line, which is going to be 1/2. So the acceleration at 12 is the first derivative of velocity at 12, which is 1/2. Is the particle speeding up or slowing down there? And explain. Let's take a look. We already know that the acceleration is positive. The velocity is also positive, so they're both positive. So we know that v of 12 is positive. We know a of 12 is positive. Since they have the same sign, not just because they're positive, but they actually have the same sign, the particle is speeding up. Speeding up. Okay? All right. Moving along. What is the distance traveled by the particle from 0 to 6? Okay, distance traveled, this is where we have to be careful, because here's what the particle is doing. It's moving to the left from 0 to 2, then it changes direction and starts moving to the right. So what we need to do is to find the total distance traveled, we need to find how far the particle traveled here, because it went the one direction, and then how far the particle traveled here. That's going to be represented by integration, right? But you have to be careful. So whenever you find distance traveled by an object, it's always going to be the integral from 0 to 6 of the absolute value of velocity. Please don't confuse that with displacement. And all we need to do here is find the areas of these two shapes. So we have a triangle here and a trapezoid here. So the triangle is 2 by 2. Trapezoid has 1 base 2, 1 base 4, and the height 2. And what we are going to do then is we're going to write all that. So it's going to be 1/2 times 2 times 2 for the triangle, plus 1/2 times 2 times 2 plus 4 for the trapezoid. So it's going to give us 2 for the triangle. It's going to give us 6 for the trapezoid, and the total distance traveled is going to be 8. What is the particle's total displacement from 0 to 6? This is where sometimes confusion happens. Sometimes students get confused between the distance and displacement. So displacement, let's take a look at the graph again. The particle is moving to the left from 0 to 2. Then it comes to a stop and then it starts moving to the right. So however far it went to the left, moving to the right is going to start canceling that. This is where you find the integral of the velocity, not the absolute value of velocity. So to find that, we're going to do the integral from 0 to 6 of v of t dt. And this is what we need to remember. Since we're integrating, there is what I usually refer to, even though it's not quite a correct term, there is negative area here because it's below the x-axis, and there's positive area here. So we still have this triangle and this trapezoid, but this triangle, this value here is going to be expressed by a negative number, and here by a positive number. So we're going to do negative 1/2 times 2 times 2 for the triangle, plus, and this is going to be positive. So what do we have? We have negative 2 plus 6, which gives us 4. What is the particle's position at 6? So the particle position is always determined by the initial position plus the displacement. The displacement is given here. Typically we write it's going to be x of 0 plus the integral from 0 to 6 of v of t dt. Okay? So we already know that this is given to us. This was given to us as 5, this value. And we already know this is 4. So it's going to be 5 plus 4, which gives us 9. Okay? So again, just want to clarify that when you do the distance traveled, it's always going to be the absolute value, the integral of the absolute value of velocity. If you're talking about the displacement, it's just the integral of velocity. All right. So the distance traveled from 6 to 16. Distance traveled. So first of all, I would recommend, let's just write, it's going to be the integral from 6 to 16. Distance traveled, the absolute value of velocity. And now let's figure out how we're going to find it. So 6 to 16. So starting here, what do we have here? We have this part that's going to be above the x-axis, so that comes out to be positive. We're going to have, basically we need to find this area, and this area here. Okay? So this triangle here, this triangle here, this triangle. We ignore the fact that some of them are below the x-axis because we're talking about distance traveled. So in our case will be one triangle is going to be 1/2 times 2 times 2. Another triangle will be 1/2 times 3 times 1. And another triangle will be 1/2 times 5 times 1. Let me show you this again. So 1/2 2 times 2, 1/2 3 times 1, and 1/2 5 times 1. So what do we get from this? That's 2 plus 3 halves plus 5 halves, right? So it's 2 plus 4, basically, which gives us 6. What is the particle total displacement? Okay. First thing that I would suggest, just write is the integral from 6 to 16 of the velocity. Oops, I keep forgetting writing dt, that's not good. Let me, no, I did write any other problems. Okay, I'm good. You're supposed to write dt. And now we have to evaluate. So remember here, the signs will mean that you might have to choose a negative. So we're going to have positive here, negative here, and positive here. So the first one is going to be positive, so it's going to be 1/2 times 2 times 2. Plus the second triangle is below the x-axis, so it's going to be negative 1/2 times 3 times 1. And then plus positive again, 1/2 times 5 times 1. So that's 2 minus 3 halves plus 5 halves. So that's going to give us 2 plus, 1 plus 2. It's going to give us a total of 3. What is the particle's position at 16? Well, we have two choices. We can either go from 0 again, but then we have to add all the distance, all the displacement between 0 and 16. Or, since we already know the particle's position at 6, we can just go from 6 and add this displacement. So what's going to happen here, to find this, it is going to be the x at 6 plus the integral that represents the displacement. So from 6 to 16 v of t dt, we already know that. We know that the position of the particle at 6, we found it as 9, so it's 9 plus 3, which is going to give us 12. Okay. Find the distance traveled from 0 to 19. Okay, so distance traveled, that means we're going to have an integral from 0 to 19 of the absolute value of v of t dt. Let's take a look at this velocity graph again. So the particle is, we're going to have this area plus this area plus this area plus this area plus that area. All that added together, no negatives here because we ignore the direction. So it's going to be 1/2 times 2 times 2 plus 1/2 times 2 times 6 plus 2. That's my trapezoid. Then plus 1/2 times 1 times 3 plus 1/2 times 1 times 5, and one thing that we did not calculate before is the last triangle, 1/2 times 3 times 2. So this triangle, 1/2 times 2 times 2, this trapezoid, 1/2 times 2 times 6 plus 2. This triangle, 1/2 times 3 times 1. This triangle is 1/2 times 5 times 1, and this triangle is 1/2 times 3 times 2. After doing all this math here, we will get 17. What is the total displacement? So when we calculate displacement, we're going to have to remember that some of them are going to be positive values, some are negative. That's going to be from 0 to 19. of the velocity v of t dt. So the first triangle is going to have a negative value, negative 1/2 times 2 times 2. Ignore this thing before it confuses you. Let me hide it. Okay. Plus the second triangle is going to have positive, so 1/2 times 2, it's not a triangle, it's a trapezoid. 6 plus 2. The next triangle is negative, so it's going to be negative 1/2 times 1 times 3. Then the second triangle is positive, 1/2 times 1 times 5, and the last triangle is also positive area. And all that is going to give us 10. So what is the particle's position at 19? We can do, since we know the displacement between from 0 to 19, which is 10, we can simply do x of 0 plus the integral from 0 to 19 v of t dt, and that's going to be 5 plus 10, and that's going to be 15. Okay, so I hope this was helpful.